Before we get too far into law of sines, let's talk real quick about just some things that should kind of be running through your head whenever you're working with triangles. And that's the relationship between the angle measure and the side lengths. If we think about a right triangle, we always know the hypotenuse is the longest side, but why is that? Well, it's across from the largest angle. Once I fix this angle at 90 degrees, it's impossible to make these equal or larger, so this is always going to be the largest side. That kind of relationship is true with every triangle everywhere. So when I look at this example triangle with sides of 21, 16, and 26, this 26 is the largest side. So I know when I'm working with my triangle that this 88 is the largest degree possible. That's the biggest angle in my triangle because it's across from the largest side. Now this example, we're going to figure out the value of angle C, then we'll probably translate that also into the value of angle B. But what do I know for sure? I know that angle C has to be less than 88 degrees. It might be kind of close because these measurements are kind of close, but all I really know for sure is that it has to be less than 88 degrees. We're going to use law of sines, where the side A over the sine of angle A equals the ratio of side B to the sine of angle B equals the ratio of side C over the sine of angle C. And we're going to fill in the information we have. Okay? I have this fixed relationship between both parts of A. So I know that 26 over the sine of 88 degrees is the first part that I'll need to use. I'm looking for angle C, so I don't need to mess with this B ratio. And we'll go straight to side C, 21 over the sine of angle C. Once I have my usable proportion set up, we can cross multiply, and I got 26 times the sine of C is equal to 21 times the sine of 88 degrees. Divide by 26. And I know that the sine of angle C is equal to whatever I get when I do this. So we'll pick up the calculator. And check the mode. Make sure we're in the right mode. The problem's in degrees, so I need to switch my calculator to degrees. And then we can just type what we're looking at. 21 sine 88. Make sure you close parentheses. Divided by 26. I get this irrational looking decimal 0.8072. I'm going to write down just the 0.8072 as a placeholder in my work. When I take the inverse sine of all of this, I'm going to use the whole value. So when I second sine and then hit second answer, my calculator knows to look back and use where all this information came from. That way I get the most exact answer possible. And I'm looking at 53 point change. So angle C is approximately 53.8 degrees. Okay? I didn't give you any instructions on how to specify or how many places to round to, so I'm just going to pick tenths right now. And we can come back and we know angle C is 53.8 degrees. It is smaller than 88. We knew that was going to happen. What do I know about angle B? Well, angle B better be smaller than 53.8. So we'll just use 180 minus 88 minus 53.8. And we get 38.2, which is in fact smaller still. Smallest angle in the triangle is across from the smallest side. A relationship you want to keep in mind, because when we start asking you to solve triangles, it may be that the triangle is not possible based on the information that's given. Draw the picture, check the relationships, and always make sure that what you're doing is reasonable.